All right, welcome everyone to the March HPC Best Practices webinar. Today we're going to hear from Peter Williams of the Center for Astrophysics at Harvard and the Smithsonian, and he's going to talk about one good tutorial, defining a minimum viable documentation product for scientific software. We want these webinars to be interactive. We'd like you to ask questions, and we will have Peter answer what we have time for during the session, and then we'll have a written document afterwards. So please use this Google Doc at the bit.ly link. I'll put it in the chat in a minute to write down your questions, and we will go through them as time permits. Also, we would very much appreciate your feedback about this webinar. And so this is a very short form, just a couple of questions. But also, I'm happy to note that Peter is a Better Scientific Software Fellow, and the BSSW team also have a survey that's a little more specific that Peter would appreciate your response to, and I'll be putting that in the chat as well. He'll mention it during his slides. So this webinar will be archived. We're going to make the recording, the slides, and the Q&A notes available. Usually those are ready within about a week of the session, and that's the target at least that we work for. Everyone who registered for this meeting will receive notification when those are available. Please feel free to share that with your friends. This is a resource we'd like everybody to have access to and share. And with that, I'd like to turn it over to Peter.
All right, thank you. Let me just share my screen here. All right, hopefully you can see that title slide.
Looks good.
Okay, so yeah, I'm Peter Williams. I'm the technical lead at the IU Minor Planet Center, and I've been fortunate enough to be supported by this Better Scientific Software Fellowship over the past year to work on a project codifying recommendations about documenting scientific software. I'm going to start by diving right into the approximately 8-minute version, where I'll give you a sort of high-level view of what I've concluded, and then I'll go into a little bit more depth. If you want to drop off after the 8-minute version, if you're, say, watching this after the fact, that's totally fine. So, to start with situating the task of writing documentation for scientific software, my first recommendation, recognize that this is a difficult task. So, documentation is really hard to create. It is fundamentally education, which I would say is a major unsolved problem of human civilization, getting information from one person's head into another. Not only that, when we're talking about documentation, we're implying some sort of tangible artifact, a website, printed material. So there's design questions of how do we structure the information that we're trying to convey. And then, especially for more modern documentation for software, there's engineering aspects. If I want to have API documentation or tooltips, I need to build software that supports what I'm doing for my documentation. And above all that, documentation is an unbounded problem space, especially in scientific software, where I could be defining scientific concepts that might have a whole textbook's worth of information behind them. It's not very clear where to stop. So this is a big challenge to write documentation that does all this stuff well. Furthermore, we're often not really having a lot of resources to do these documentation projects. Often it's kind of done towards the end of a project, and you're probably going to be a very lucky person if you have tangible time, money, personnel dedicated to documentation projects. The combination of this can lead for a somewhat demoralizing experience. So what I would recommend is, if we're considering a new project, one that's starting out, try to target what I'm calling a minimum viable documentation product. So you may have heard of this MVP, minimum viable product concept before. The Wikipedia definition is what shows on your screen here. So the idea is basically, okay, documentation could be a lifetime's worth of effort, but we need to start somewhere. So let's focus on really the least we can get away with. And hopefully we will have the opportunity and the motivation to add onto that, but let's start small. So this is sort of a realistic approach in the sense that, once again, your resources are likely limited. You're often not working with a lot of time, but I also think of it as an optimistic approach in the sense that, uh, we're starting somewhere, but very much with a recognition that it's not going to be perfect. It's not going to be fully comprehensive. It's the first step of what may, with luck, be a very long journey. So, in a certain sense, this mindset is all about giving yourself permission to not do the best possible job, but to do a job that's just good enough. So, during my fellowship, I spent some time considering the question of, can we define a generic minimum viable documentation product for scientific software? And as you might expect, my claim is actually yes. So if you look at the broader technology ecosystem, you go to AWS or any kind of technology product, you will almost surely see a big getting started button on the website. And this is backed by a lot of industrial research, I'm sure, that the most important thing, if you've got some kind of thing that you're trying to get people to use, you need a sort of tutorial that they can dive into and get started with as quickly as possible. And in the modern context, that means something that's online, where you can pull it up and just click away and start going. So an important thing to think about is this is what we need for new users or potential users. And especially if we're talking about a new project that's just getting launched, that's really your biggest, the most important market to address. So if you want to think of it in kind of marketing speak, we can talk about conversions from people who know about your software or are aware of it to ones who become actual users. And a side effect of working on, especially this, making sure that this tutorial is high quality, is that you build trust. And it's amazing what kind of stuff you can get away with uh, once you've built that trust. If you provide a really good experience off the bat, other stuff that you might look at and be, say to yourself, this is terrible. I can't believe people put up with this. But if you've like gotten off on that good fit, people will forgive an amazing amount, which is a good thing. My claim is that for your MVDP, this is the most important thing. You need other things, but honestly, not a whole lot more. And so what I developed as part of my project is a checklist. This checklist essentially defines a minimum viable documentation product for scientific software. It's got 9 items, which you can see here. So there's a synopsis, the tutorial that I've just talked about, contact information, installation instructions, citation instructions. That's an example of something that's more specific to scientific software, a contribution statement, reference material, a licensing statement, and acknowledgments. And I believe that if you provide these 9 items, obviously, it's not going to be covering every possible piece of documentation you can write, but that's the key stuff for your project to get off the ground. And I've chosen to express this as a checklist rather than, say, like a recipe or kind of a set of steps, because the really idea is, this is what you need to have. How you get there isn't necessarily the most important thing. This checklist is online at the website that I've created, onegoodtutorial.org, which also has a bunch of additional resources that I'll talk about a little bit more as I continue. But this is the key thing. My claim is go for these 9 elements and you'll have something that will be just enough. As your project goes on, you'll probably need to add more, but this will get you started. If you're not sure how to get started, I've also created a thing that I call the playbook, also at the website, which gives essentially a recipe for starting from zero and building up all of those 9 elements. It's delivered as an HTML slideshow on the website. I found that to be a very nice form factor for giving kind of progressive information about things. And to be honest, most of what it recommends is nothing too earth-shattering. I've had bullet points for a few of the perhaps more interesting elements there. So I suggest that you create something like a Google Doc for taking notes as you develop things. I suggest using a technique of user personas while you're working on your documentation. A few elements like that. One thing to mention is that along with this checklist and this playbook, the main content of the website has a lot of in-depth guides that give more detailed information about writing these different elements and some of the approaches to working on your documentation. The final thing I want to recommend is, as I mentioned before, writing documentation really is sort of the kind of problem that is structured to be very frustrating. And so one nice thing about the checklist is when you're done, that's a very tangible achievement. and you can celebrate it. So we have a badge that you can deploy. And of course, not coincidentally, the badge helps promote the project, which is, I would like to think, a good thing. So that's a very short version. This is a conclusion slide basically for the archived video. So if people are watching this on YouTube, here's my key acknowledgments and a link to the feedback survey that David mentioned. But I'll keep on going for those of you who want to learn a little bit more. So what I will do now is dive into this playbook that I mentioned, and I've reproduced it as verbatim in these slides, and I'll talk through things a little bit. So that playbook, because it's designed to be something that you read and consult on your own, it's a little bit more verbose and wordy than slides that I might give in a purely interactive presentation. Um, but I figured it would be best to really stick to exactly what is on the website. So this playbook starts with a few preliminaries, kind of throat clearing things. I'll run through these relatively quickly. So talking about the intended audience, this has probably been pretty clear, but I am mostly targeting people who are working on relatively small and informal projects. If your project has a documentation team, I'd like to think that some of the things that I talk about might be interesting, but probably you'll be working in a pretty different mode than what I'm talking about. Uh, I'm aiming at scientific software, something like citation instructions is pretty specific to that. But that being said, I'd like to think that a lot of the recommendations will be helpful even for non-scientific projects. Likewise, most of what I have in mind is aimed at open source projects. But once again, if you're not quite that, I think a lot of the same rules should apply. Uh, One thing that I believe pretty strongly is that in the modern world, when we're talking about documentation, we're talking about creating a website. Sometimes you'll see software that targets a PDF, say, and when you are working in the scientific mode, you might have equations and references. There's an appeal to that. But in terms of searchability, accessibility, I would claim that HTML is really the only form factor worth targeting. So essentially, this means that when you're creating documentation, you're creating a website. Historically, this has raised the barrier because you might need to register a domain and learn how to set up a web server and all that kind of stuff. A nice thing about the modern ecosystem is that there are services like readthedocs.org that can really take care of a lot of that for you in a way that really lowers the barrier in a way that's one of the really great innovations of the ecosystem over the recent years. Um, as I say here, above all else, hopefully it goes without saying that this is a recommendation. If there's parts that you don't like, ignore them. If there's parts that you do like, feel free to steal them and drop the rest. So getting to actually working on things, I recommend reserving some time for planning. If we're working on something like this, inevitably it's nice to dive right in, but it's probably best to spend some time planning things out a little bit in advance. That's just good for almost any human undertaking. So I recommend starting with creating a note stock. So this will be something that's just a place to jot down drafts of things, ideas, background information, specifically not something that's going to be public, not something that will, you might share it within your collaboration, but not beyond that. It could just come in handy. It doesn't even need to be digital. If you want to do it on paper, there's nothing wrong with that. I recommend you start with a synopsis as the first thing that you actually write originally. So this is a very short summary of your project, and in my opinion, it's helpful to have this kind of work on this kind of 10,000 foot view of your project. Why does it exist? What is it for? When it comes to scientific software, you probably want to be pretty specific. Uh, you can get into kind of marketing ease about we're going to revolutionize synchrotron spectrum calculations. But in the world of scientific software, your potential users probably have very clear idea of what they need, and they want to know whether your software will meet those needs. So sticking towards um, being very specific, and inevitably there will probably be some jargon, but a lot of the tension here is trying to be specific without getting too deep if there's someone who realistically could be a user of your software and isn't necessarily, say, going to know what a finite volume approach is. Um, there's trade-offs there. But the earlier you do this, hopefully that sets the stage for guiding your thinking about all the subsequent steps. So you'll see at the bottom of this slide, there is something that says in-depth guide. So this is a lot of these slides have links to these in-depth guides. So I'll actually click on this one. Um, so this is an example. In this particular example, it's relatively short of some of the guides that are available on the main website, where they just provide a little bit more information. I often try and give a lot of examples about the topic in question. So you'll see these links depending on if you're looking at a saved version of the slides. Hopefully they should be live, or you can just go to the onegoodtutorial.org website and go there. There's an index of all of them. So the next thing I recommend is this idea of planning up some personas. So this is something that you might be familiar with from user experience design kind of side of things. So the idea is basically to spend some time coming up with a imaginary but specific person who might be using your product, your software, and your documentation. Um, in bigger efforts, people can really spend a lot of time on this and really put a lot of effort into building these out. I think for your typical scientific software project, this is something that you should be spending tens of minutes on, not hours. But it's very helpful because it's good to target a specific use case, not sort of instead of a generic user. So for in the example here, a postdoc who wants to use your software, but also has a lot of other things to do and is really not going to have much patience if you put many barriers in their way to using it. Or you might imagine a senior person who maybe they actually don't even really care about your software that much. They're more interested in trying to evaluate, or they're not interested in using your software that much, but they're evaluating what you've built and whether they should recommend it to someone else, for instance. From there, the next planning step I recommend is since the tutorial is so important, try and outline it early. Uh, Once again, just good practice for anything that you want to do well. So I think it's important here to really, we're not drafting the text. We're just kind of planning out what it's going to be like. So think of it as a storyboard or an outline. Um, and the earlier that you do this, the earlier you can think of potential pitfalls where you might have something that you want the person to do, and you might realize this is going to require them to copy paste 30 lines of boilerplate code. In that case, probably you should develop some kind of function that makes that boilerplate turn into just a couple of lines. Um, you're not going to catch all those things in a early outlining phase, but it helps you think through the flow. And also, part of the point here is to really isolate. So, what can I show people about my software that gives them a very really you're holding their hand the entire way. You want to show them something about why your software is special. You can't show them everything about your software, most likely, um, but you want to show something distinctive that gives them the idea of why they might want to keep on using it and spend more time learning about it. Once that's done, I recommend starting to draft some of what I call a little bit reluctantly the easy documents. So a lot of the documentation elements of my checklist are things that could potentially be very short to write, and if you have done them before, might not take much effort to prepare. And so this is nice kind of stuff to get started of getting some words on paper that hopefully aren't too challenging. For instance, contact information. So you should have something that tells people how to get in touch with you. This is really a dual purpose thing. So first of all, for a small project, one that's just getting started, if people have questions, almost surely the best way to try to handle them is contacting you directly. That could be GitHub issues or even a pull request sometimes. But there will be cases where you basically just want to give them your email address or some way to reach out to an actual human directly. Um, the contact information also documents who is in charge of the software. And this is a good example of something that, as your project hopefully succeeds and evolves, those two purposes might bifurcate into two different documents, one about getting support and one about documenting project leadership. Uh, I'll note that for generic open source soft projects, a lot of people write them under pseudonyms. I think for scientific software, when someone might want to reach out to you and understand who's funding this or about writing a proposal together, things like that tend make it more important to document the actual human who is behind the things. Installation instructions is another one. So here, my advice is a bit opinionated. I believe that in the modern scientific ecosystem, or even the broader software ecosystem, there's a lot of really nice packaging tools now that mean that in most cases, your instructions can and should be very short. Uh, if your package is monolingual, there's probably a package manager involved, and your primary instructions should be use that package manager. Um, for things that combine multiple languages, this used to be a much more fraught landscape. My personal opinion is that nowadays the Conda system has pretty much been the dominant player there, and the open source Conda Forge project provides a way to build packages for projects in a way where you have to learn how to use the system, but you can come in and provide your own packaging instructions and get things integrated in about as easy of a fashion as you're going to find. Um, in the HPC context in particular, this can be more challenging. Sometimes people really do need to compile things themselves. Um, but I think the aspiration should be uh, it should be short. And if it's not short, this is probably something where it's not so much about documenting it, it's about improving your processes, your build instructions, whatever it takes to make it so that your installation instructions can be short. Once again, there are plenty of exceptions here, um, but this is the kind of thing where sometimes people will try and document, okay, here's the really complicated recipe, and they do a really like thorough job of writing down all the possibilities. What I would say really the solution is get rid of those possibilities, clean things up on your side so that what you have to document in the end, there's just less to write up. Um, the exact details will depend very much on your language, your target users, your target platforms. So in this case, the in-depth guide, I provide a few examples for, say, a pure Python package, but obviously I can't cover every possible language under the sun and every possible deployment scenario. Um, but I think the general principles will hold. Citation instructions. This is another one where when things go well, it might be very short, but citation is a very fraught concept. Different fields have different ways of doing things, so there's a lot of variability here. Ideally, when it all is said and done, most of the effort once again is at the back end of making your software citable, and once you've made it citable, telling people how to cite it is hopefully pretty straightforward. Um, One of the wrinkles here is that in a lot of places, as an example here, you might write a refereed paper about your software, and that paper is essentially the proxy object that people cite to count as credit to your software. But it is possible if you deposit your software to Zenodo or write it up in the Journal of Open Source Software, the software itself can be a citable object with a DOI, and it's better to cite that object directly instead of, say, a journal article, which is kind of this indirect proxy. But then different journals have different policies about how to cite uh, things that aren't journal articles. It does get a little gnarly. This is a field near and dear to my heart, so I've probably written too many words in this in-depth guide. But it's important for scientific software. I think part of almost anyone who works on scientific software is aware that the credit that we get for doing it is not always aligned with the work that we do and the value that it provides. Um, and fundamentally, my view is, to fix that, we kind of have to jump through these hoops of learning these tools of making things citable, DOIs, all, citation.cff files. There's all this stuff, and it's not as easy as when you can hand a journal article off to a publisher and they take care of all that for you. But for better or for worse, that's kind of the work that part of the work that we need to take on when we're producing scientific software. A licensing statement, this is also very important. So technically, if you just throw some software up on GitHub with no statement about the copyright status, the default assumption under the Berne Convention, it's intellectual property, it's all rights reserved. Theoretically, you're not even allowed to download it because it's making a copy of it. Um, so if you haven't thought about software licensing before, I'm afraid that you just have to learn a little bit about it. That's part of, once again, the things that we have to do when we're putting software out there. In the end, your documentation might be a single sentence. You might be saying we're licensed under the MIT license or some other open source license. But there is some work behind the scenes to understand these things. I recommend the MIT license as it's an open source default. It's short enough where you can read it and understand it yourself, different fields and different practices. And another thing worth mentioning is when you're creating scientific software, you're probably doing it in an institutional and funding context. And those people, like your university or lab, might have an office full of people whose only job is to manage the intellectual property that people at your institution create. And whatever you do needs to be consistent with those policies. Um, Theoretically, when I was a grad student at the University of California, everything I wrote should have been property of the Regents of the University of California. We got sloppy about that, but every institution that hires scientists, almost every institution is going to have rules about that kind of thing. The acknowledgments, if you've been funded, you should, sometimes you're required, sometimes it's at least a very polite thing to do is to record that. Um, And I'll just mention, if you end up using the One Good Tutorial checklist or other resources, you are encouraged but not obligated to acknowledge it as well. A contribution statement. So by this, I mean something that tells people if they want to get involved in your project, how they can do so, or if they can do so. So this is something that's a little bit specific to software. If I put out a refereed paper, people might write another paper building on it. But software tends to grow and evolve in place. And so someone using your software, they might say, hey, I have a bug fix, or I have a new feature that I'd like to add. And how you want to react to those requests is a decision that you have to make, but you should document what that decision is. And I would recommend, uh, honestly, you're very lucky if you get people coming in wanting to fix bugs or add new features. I would recommend for a new project a few sentences that are encouraging, saying, hey, if you have something to contribute, file an issue on GitHub, reach me, use the contact information. That's probably all you need. As a project evolves and matures, this is another case where some projects have quite substantial contribution guides that can even get to details of variable naming and how to design tests. Um, but if you're just starting out, uh, you can do a lot less. I'll also mention that this is the kind of thing where other projects that already exist, like in my example, AstroPy, they have a contribution statement. You are entirely welcome to copy it, search and replace AstroPy with the name of your project, if, of course, you agree with what they're saying. And if you do so, you should give credit to the source statement. But this is the kind of thing where there is no need to reinvent the wheel. If you see someone that has a contribution statement that you like, um, build on it. That's the open source way. Um, Other things like other some of the other documentation elements can also be like that in some cases. So we've drafted some of the stuff that is relatively easy, although if you have to go rework your entire build system to improve your installation process, that might take some time. The next stage that I recommend is getting the tooling going so that we can actually build our documentation. And what I strongly recommend here is an approach that's sometimes called docs as code, where the documentation source materials are in the same repository as your project itself, and the documentation build steps are integrated into continuous integration or deployment systems. Um, so much of the way that, say, in Python, you've got doc strings integrated right with your functions or whatever it might be. That's very popular because it helps things stay up to date. And the overall docs as code approach also supports that, even for you might have a narrative tutorial, but if you are good about keeping it updated when you add new features or change APIs, it just helps things a lot of ways. At a certain level of complexity, there might be other approaches to consider, but I would say, unless there's a compelling reason not to, having the docs integrated with your main source repository, and especially leading into integration with continuous integration tools, is really valuable. So one step towards this is scoping out sort of what will comprise your final MVDP. So if you go back and review all the elements I've mentioned thus far, it covers everything except the reference material. And you might, upon reflection, maybe you need something else that isn't in the checklist, but in your opinion, does need to be part of that initial product. Certainly, the checklist is a minimum, not a exact specification. Um, so as we start building out the skeleton of your documentation and the tooling to do it, now is the time to assess all that. Um, in terms of tooling, I want to separate the idea of the authoring tool, which is, say, the system that you're going to be using to actually write your documents and probably convert them into HTML. And what I'll talk about next is the publishing tool. So, for example, if you're writing a project in Python, you might use Sphinx. And often what drives the selection here of what tool you're going to use is if you're writing in a certain language, that language probably has its own specific documentation tool that can create its API documentation. So Sphinx for Python APIs, RustDoc for Rust, etc. The API documentation tends to be the most challenging material, just mechanically in terms of how to format, and often those tools are integrated with this docs as code approach of slurping out doc strings or things like that. And then everything else that you need to prepare, like your licensing information or contact information, those tools can do that stuff too. So probably the selection of tool will be driven by whatever integrates best with your implementation language. If you've got a lot of code in multiple languages, that's when you might need to kind of step back a bit. Alternatively, if you really don't have much in the way of API documentation, um, maybe everything can just fit in a readme.md. You can completely satisfy my checklist with a readme that's of a fairly modest length for the right kind of project. Once you've selected that tool, then there's the work to kind of set it up in your source repository, and you could either copy over the things that you've already drafted or stub out things like your tutorial that you haven't really drafted. And hopefully at this point, you can do a build. You could look over kind of the site skeleton. Um, and now is also a good time to review templates and theming. It'll be really a lot of documentation tools will have a gallery of themes if almost all the tools support some kind of theming. And it's pretty incredible how within a very tight set of design choices, the wide range of themes that you can find. And I think it's worth spending some time reviewing that kind of gallery if you can, seeing what works best for you, what you like the most. Um, when you have the skeleton, you've thought about the material that you're trying to publish, you've got your initial framework, so you can think, it's a good time to think about how to organize things. What I've recommended is amenable to a very flat organization. This is one of the slogans of Python that I think is valid beyond that one particular language. Flat is better than nested. Um, you know, I've generally found that until you get a whole lot of material, a fairly flat, straightforward structure is probably the best approach. At this point, we want to think about this publishing stage. So your authoring tool lets you take your source files. They might be markdown files. It might be some of your source code that doc strings are extracted from, probably build some HTML. And then there's a question of how we publish that to the outside world. Um, there might be strong integration between an authoring tool and a publishing tool. If you're using Sphinx for Python, you will at least want to consider deploying to readthedocs.org. If you're using a Rust project, it might automatically get published onto docs.rs. Um, if you don't have those things, almost all the tools that you are going to be using for publishing for authoring can probably create a kind of static HTML tree, and those can be published via GitHub pages or GitLab pages or various other static website publishing systems. I do also strongly recommend, if you can wire this into your continuous integration system or continuous deployment, if you have separation between your testing and making releases. Um, it's automating this kind of stuff is hugely beneficial, I've found. All right, so we've drafted some of the more straightforward documentation. We've got the tooling in place. This is the part where a kind of step-by-step playbook starts falling down, and the steps start becoming things like, okay, now you just kind of have to write stuff. Um, it was inevitable, and we've put it off for as long as we could. So I recommend starting with drafting the tutorial within your documentation tool. So the tutorial might be something that, compared to, say, a contribution statement, this might be something where you want to kind of go above and beyond in terms of your authoring tool. So you might want to make it into an interactive notebook or some kind of interactive web app that lets people do things more actively. So nowadays, there's lots of nice tools that help you, say, take an IPython notebook and convert it into various outputs that might integrate with a Sphinx documentation tree or whatever authoring tool you might be using. Um, so it's good to work on that first and get that integration going. Um, yeah, there's only so much help I can give. It's going to be very context specific, but I will have some links later for some resources about things that might help you think about how to compose this material. After that, there's everything else. So if you are sticking to the 9 checklist elements, what's left is the API reference material. Um, and one thing I want to emphasize here is if you're using a tool like Sphinx or whatever language specific API tool, it's kind of easiest to start work on the API documentation. Depending on the size of your project, getting really 100% coverage of that can be a lot of work. And my argument is that until your project is very mature, that's not necessarily the most important thing to aim for. Um, it's always disappointing to click through API documentation and find whatever thing you're curious about, and there's nothing there. But that's someone who already knows how to use your project and has gotten invested enough to even have the question to ask of what is the exact definition of this parameter. Someone like that is already, you've already converted them into a user. Um, and given that there are only so many hours of the day, uh, you can write a minimal set of API reference material, leave parts blank. I think for your minimum viable product, that's totally fine. If you've got enough time to fill it all out, so much the better. But there's always going to be a trade-off about where to put your energy. So at this point, we're in the home stretch. So once again, best practices, no matter what kind of thing you're doing, it's good to step back a little bit, review, revise. Often, what I would do at this stage is I might go over my tutorial, and whatever the tutorial references the concept, the tutorial isn't the place to be like, I'm going to teach you in detail how this particular API function works. But it is a place where you could add a crosslink to the reference material that you've just written, or potentially other documentation elements. Uh, Adding that kind of dense cross-linking, in my view, is really kind of what differentiates well-constructed documentation from kind of the initial first pass is building up that dense cross-referencing throughout all of your materials. Um, and once again, you might read something and be like, man, this is a lot of words to describe something that really could be a lot easier if I just make some change to my implementation, default a parameter or whatever. And if you have the energy at this stage where you're probably very close to releasing, you're probably short on energy, honestly. But if you have the energy to go back and look at and be like, man, this is just like too many words for what I'm trying to get across here, that's your sign that maybe you can change something about your software to make it so those words aren't necessary. And that's essentially the end of the playbook. So at this point, you've gotten a first draft. It's certainly not perfect, but it exists and you're able to publish it. So I would say the next thing to do is go ahead and publish it. And this is a good time to potentially add a badge to your README, take a walk, look at some dogs, whatever makes you happy. One of the things about documentation is it never feels like you're done. There's always more that you could do, and usually when you've just written all this stuff is when it's strongest in your mind of all the ways that it's coming short of what you wish it was. So it's important to fight that and to associate this effort with something rewarding. So for these slides, part of what was mentioned at the beginning, there is a feedback form for the Better Scientific Software group about this particular resource. I'll have a QR code and an actual URL in a minute, so don't worry about that right now. But if you do have any feedback, you can reach out to me directly, or you can send it to the BSSW team, and at your request, they can forward it to me or not. So that's the end of the playbook that you'll find. So just a few more words on the implementation details. If you're familiar with it, you might suspect and be correct that a lot of this project owes much to something called diataxis. It calls itself a way of thinking about and doing documentation. The diataxis website is diataxis.fr. It used to just be called the documentation system. I think that was a little bit hard to talk about. Um, I think so. This is as things go, this is a fairly well-known idea, and I think it's a really powerful starting point for thinking about documentation. The argument of diataxis is that we should think of there being really different kinds of documentation. It's not like I write the documentation. You have different things that you prepare, which are basically aligned with different user needs. Diataxis in particular sets things up in this quadrant system where they say we can divide everything into four categories: tutorials, how-to guides, explanation, and reference. So you might notice that in my checklist, I've called out tutorials and reference material. I haven't called out how-to guides and explanations. And I would claim when you're just getting started, I think that's okay. I think your minimum product doesn't need to have some number of explanations. Um, as you go on, those are exactly the kinds of things that you will hopefully find yourself needing to add. And the Diataxis website has some great discussion of how to think about these things, specifically for how to structure tutorials. I alluded earlier. They have a lot of ideas that I really endorse about thinking about the tutorial as an educational thing and what we're trying to achieve when we're teaching people in that form factor. It's You're kind of sneakily teaching them. You're not explicitly saying we are going to learn the difference between, I don't know, synchrotron and cyclotron, but you are showing them how to do something, and in the course of doing that, they start learning these concepts. I believe that's a generally useful approach to that kind of teaching. Um, Stepping back a little bit, so if you go to the Diataxis website, it's mostly documentation. Diataxis itself is an explanation. It's a way of thinking about documentation. Whereas the One Good Tutorial website tries to be more of a how-to guide of walking you through what I've just walked you through, some specific steps to get things done. So hopefully in combination, they'll be a valuable pairing. Just a few words about how One Good Tutorial works behind the scenes. I've basically endeavored to make it pretty boring. It's a static HTML website. It's built with a tool called Zola that I like a lot. As you may know, there are dozens of things that will build static websites for you from Markdown. I have my reasons for preferring Zola. Honestly, they're not too important. It's served by GitHub Pages. I've got a link here to the GitHub repository. One thing that I will mention that is perhaps more unusual is, as I've alluded to before, I've really leaned into continuous integration and release automation tools. Uh, One good tutorial uses a tool called Cranko, which, full disclosure, I wrote myself, um, which integrates releases and release processes with something like GitHub Actions so that you can automate them. In particular, the way it works is every time I update the website, I make a new release, it gets a new version number, and also I deposit it onto Zenodo so that the website has a DOI for every version. And the way that the automation works is it knows about its own DOI. So if you go and visit it, it will have a link. It has example BibTech that automatically, when I make a new version, the new DOI is pre-registered. I update the website content to contain it, and then it all gets deposited. Um, compared to a more manual process where like whenever you want to update the DOI, you have to log into the website manually and type stuff and do stuff. I cannot endorse strongly enough the value of building automation for this kind of thing. And certainly this is what I use for all my scientific software as well. Um, is I use the same kind of framework so that the software knows its own DOI. So like when you run the software, it can tell you this is the DOI that you're using right now, cite it, as opposed to a lot of software citation recommendations say like, oh, you have to go back to the website and then like find the DOI, and maybe that's not the version that you were actually running. And fundamentally, a lot of this comes down to a technical question of having the software being able to know what its own DOI is, which can be a bit tricky, but it is a solvable problem. A couple other things. So I do have some analytics using a relatively lightweight, cookie-free, privacy-respecting system called Goat Counter, which is free for modest projects. I'd recommend it for scientific type things. It's not nearly as invasive as Google Analytics or the free things provided by corporations are of course free because they're surveying you. Goat Counter is just lightweight. Um, and things like including open graph tags in the HTML code so that when you paste a link into Blue Sky or Slack or whatever, it has proper previews. These are kind of the sort of extra things that in a modern website, you kind of need to jump through these hoops in order to really have the experience be as good as it can be across all the ways that people are accessing web content these days. So here's that conclusion slide again with my acknowledgments. So this QR code goes to this BSSW feedback link. There are also the URLs here. A couple other links to the GitHub repository and to the main website. Um, so that's it for the prepared material. I'd like to thank you for your attention and apologize. I see that there's action in the chat. I haven't been able to check it. But I will be happy to answer any questions interactively or the chat. David, I don't know if you want to MC that right now. Thank you.
Yeah, absolutely. Thank you, Peter. The chat is just mostly me reposting links so people are aware of them.
Great.
And with that, I want to request everybody as you're heading out of the webinar, please don't forget to provide feedback. It's very useful to us in various ways, both to tweak things and to help justify the continuation of this activity if you find it useful. So we do have a fair number of questions, and let's try to work through them. I'm gonna start at the bottom of this document and work my way back up. So first of all, how might the use of AIs for retrieval augmented generation and documentation and example generation lead to adjustments in the guidelines you presented?
Yeah, so you might notice I didn't mention AI at all. Um, I do think that those kinds of technologies are going to transform some elements of documentation. I suspect that in the not too distant future, especially when we're talking about reference documentation, um, you know, traditionally for a lot of projects with Python APIs, you go to a website, there's some table of contents and structure modules. I kind of feel like pretty soon the default will be a search box or a query box, and you type a question, and the LLM slurps out the relevant material and synthesizes an answer for you. Um, for something like examples, synthesizing them, uh, I can also imagine, I don't have a lot of experience doing this hands-on myself, but you can imagine tooling that will help you crank out examples. And examples are also like really, I didn't mention this, but for reference material, that's probably the number one thing is providing small scale snippets of how things work in practice. Um, so I think they're going to be transformative. I do think for something like I would be pessimistic that you could ever just go to Claude and type, write my documentation for me, and it will spit something out. By definition, when you've created your software, you've built something new, and hopefully you are the best person qualified to explain what is interesting about it, what is new about it, how it fits into the landscape. Um, but yeah, I think when it comes to generating prose, I would certainly always recommend, you know, I would only be comfortable with something where I was proofreading material very carefully, or I love testing convincing me that the rag or whatever was not going to be, uh, a 1% failure rate is I talked about trust early on. If your system gives people advice that is just plain wrong sometimes, that's going to be one of the ways you're going to lose trust pretty rapidly. Um, but yeah, I think especially for things like the reference material, if you can train something on that material and it can really do a good job of synthesizing different elements, pulling different examples that are in some kind of backend. Um, yeah, it'll be transformative for, I think, you know, the lagging thing will be a lot of people will still expect to go to a website and see a table of contents and changing your mindset from that to just being able to type it in. Or another thing I'm not familiar with is I believe there are ways where like, okay, I'm using Claude interactively or whatever it is, and essentially pointing it at the documentation and saying, pull your answers from this. I don't know what the tooling is like for like a lot of the work of building documentation might be making that kind of work as well as possible, where someone is pointing their language model at your backend resources and synthesizing them all. Probably you'll put as much effort into making sure that that works well, no matter what someone points at your materials, than you will polishing the layout of your website or whatever it might be.
Right. So a related question is, do you have any thoughts on essentially the content, writing, what kind of content you should be writing for LLMs to consume?
Um, I don't think I have any special expertise there, so I feel like you want to focus on the distinctive stuff, the stuff that is not already going to be able to pull off Wikipedia. Like if you've got a really great explanation of X-ray spectroscopy that no one else has ever written, then that's worth putting your points into. But probably what you should be focusing on is, imagine your LLM is reading this documentation. Like, what are the perturbations that you want to apply to it so that it knows what to do? So, or so that it kind of can give people a meaningful answer. Um, so focusing on something like the maybe longer than the synopsis, but really situating your project in its broader context. Um, Also linking things. Okay, we use, you know, linking it with prior art and kind of the techniques that you've used, both the differences and the similarities of, oh, this bit is a Merkle tree, and then okay, we can pull up and dive into understanding Merkle trees if we need to. Um, Yeah, I think that's all I want to say because I don't have a lot of experience in that besides beyond that.
All right. So in a different direction, is it better to have a separate person or a separate set of people responsible for documentation, or should the team that develops the software be responsible for writing the documentation?
Ooh, that's a perennial thorny question. You can imagine on the one hand, the people who are writing the software, in some ways they know it the best. On the other hand, one thing that I didn't mention was testing your documentation. And often the people who know it best are not the best positioned to teach it to someone else. Um, So I guess this is probably a bit of a cop-out answer, but a little bit of both would probably be good. Um, I think, realistically, for a lot of small scientific software projects, having someone external working on it is unlikely to be your only answer. But if you're preparing something, one of the best things you could do, I probably should have given this its own slide, um, is getting an outside person to look things over, the tutorial above all else, but really all elements and making sure that it makes sense. So I would frame it as probably you want to originate it with the people who are building things. Ideally, depending on how your project is structured, maybe there's people who are really like developers in the trenches and maybe scientists that are slightly more detached. But getting that user feedback, that testing of how it works in practice, um, that's probably the one kind of extra credit thing, most important extra credit thing beyond what I've put so far.
And then a question that's kind of related to that, are there ideas for making documentation easy for non-coders to contribute to?
Yeah, so this is actually a topic very near and dear to my heart. So I mentioned this docs as code idea, where there are a lot of advantages to integrating the doc code, if it's like markdown files or whatever, with your repository. But as implied in the question, that does add this barrier of contributing to the docs that requires becoming, being comfortable with Git. And you might imagine, especially in scientific software, maybe you have scientists who really know the subject matter area, but don't have Git. Like for my field in astronomy, Overleaf, kind of the Google Docs for LaTeX, has taken over. I would never ask some of my collaborators to write a paper using Git as version control, even though I would be happy to do that. But they're all happy to use this kind of Overleaf real-time editing experience. Um, so I'd say for a sufficiently large documentation corpus where you like have those scientists who have a lot to contribute but aren't necessarily going to want to make pull requests, it might be worthwhile. So there's things like I think Gitbook is more of that experience, even though it's got Git in the name. I'm aware of this actually really neat accounting software called Bean Count, where they have some fancy system where the documentation is edited in Google Docs and then kind of imported through an automated system. I don't know if it goes straight into a repository, but it's kind of formalized into HTML. Um, I think there's a lot of interesting work in technologies called CRDTs, where you can get the combination of that interactive live embedding editing, but also download the data product onto your computer and manage it. Um, where, yeah, I think, you know, the kind of the wiki, it's kind of a wiki experience, which I think there's a lot of room for improvement in the tooling there. But all that being said, the advantages of docs and code are sufficiently strong that I think that's almost surely the best way to go, except in rare, large circumstances. Another thing to consider is you could kind of bifurcate your documentation and core stuff, probably reference stuff is in the repo. Maybe you've got Google Docs or something. And then you kind of have to try and figure out a way to hopefully present them under a somewhat unified interface. So that's once again, that's at a sufficient scale that becomes something that's worth thinking about. Um, but you do need a scale, I think, to make it worthwhile.
All right, let's try to get one more question in before the top of the hour, and maybe there'll be, if you can hang around for a few minutes, Peter, maybe we can get a couple more after.
Happy to.
So how do you make good documentation keeping multiple users in mind? Um, documentation for example, setting up access could have different steps and routes depending on where users are coming from. You wouldn't want to bombard users with all of the information.
Yeah, this is a really tricky question. What you'll notice in some commercial products is that they end up having kind of different portals for different user profiles. There'll be like for the developer landing page, they'll link to a certain set of things. And for, I don't know, like the CEO decision maker page, they might link to other things. And one way to approach it is, yeah, thinking of it as having different landing pages or portals aimed at different user profiles, which then provide links into the kind of common substrate. And some of those multiple pages might link to the same thing. Sometimes they might link to disparate things. Um, Another thing is so within a single document, you might have similar kind of disclosure boxes or ways to try and separate things. I think ideally, so ideally, or not ideally, but sometimes you kind of just need to write the same thing a few different times for different target use cases. And you can imagine maybe LLMs will be, I could imagine building the infrastructure to kind of have one source material and then using an LLM in some fashion to tweak it for different presentations. That seems like something that would be an engineering project in and of its own. And so at a certain point, just writing the same thing in three slightly different ways is going to be a better approach for some people. Um, but beyond that, I think you can think of you've sort of got your base layer of all your documentation, and then some sort of higher level landing pages or selections or kind of ways to make to guide people into that content, and separating out the user use cases in those entry points, but having everything sort of be in a common substrate beneath that, I think can be a good way to address that.
All right, let's hit one last question. We're a little over time, but this I think gets to your discussion about the diataxis framework. So do you have suggestions for when a team has multiple documentation sources that might overlap, e.g. some internal documentation, some user-facing documentation, administration, but targeting different audiences?
Yeah, I mean that's it's challenging. One, depending on where you are, like possibly the answer is slurp everything together and put it into one unified new everything that does everything. Uh, I think often when you're coming from that scenario, there are very good reasons why you can't actually do that. Um, and it so this is kind of at the beginning when I talked about docs being a design and engineering challenge. Um, you can imagine that, okay, I've got three corpuses that I want to present to the world. Ideally, they would be in some kind of unified interface with some kind of potentially single URL structure and able to cross-reference between them cleanly. In practice, that's a really challenging engineering problem to make that possible. Um, so in some cases, you might really have those, say you have three different corpuses, they might get exposed under three different domain names, and it's just kind of a manual effort of cross-linking between them when appropriate. You might be able to provide some kind of shell that homogenizes them a little bit, but still, if you click through to the stuff that came out of the wiki, it's going to look a little bit different. Um, Once again, if you're going to try and homogenize them all, maybe the answer is put it in the LM blender and tell it synthesize everything, spit it all out. Um, but yeah, like I don't know if I have any great advice besides like recognizing that that is like it's a real challenge on a variety of levels, engineering and design. Um, if there are ways to gradually harmonize things, be try and be thoughtful about what is the purpose of each of these things. And, if we're writing the same kind of document in three different places, that's probably a sign that we need to kind of clarify our thinking about what belongs where. Um, but yeah, it's a assuming that you're not able to just blow it all up and build the one new thing that combines them all from, fresh. Uh, like you'll probably have to build tooling to merge things, or just accept that the user experience is not going to be as unified as you wish it was.
All right. Thank you very much, Peter, for an excellent presentation, a tutorial about your tutorial in a sense. And thank you all for attending. As I mentioned, we will have the recording and the Q&A and the slides. The slides are already up actually, but we'll have that all up fairly soon. And if you registered, you'll get notice when that's available. Please feel free to share it with your friends, and please don't forget to provide feedback if you have a few minutes. It won't take much of your time, and we appreciate it. Thank you all very much. We'll see you at the next webinar.
Thanks, everyone.